Okay, so now we're going to quickly do some division. We really don't have that much. We only have 6 more slides. The bulk of it is multiplication. Division ends up being tending to go a little bit quicker. So when we're talking about dividing, we're trying to find factors or things that are the same in the top and the bottom, so the numerator and the denominator. So in the first one, and we want to factor those out. In other words, cancel those out or divide them out. So I have a 3xy over an ax. So the top has a 3, an x, and a y, and the bottom has an a and an x. So the thing that's common in both are these x's. So I can cancel those out or divide them out because anything divided by itself is 1, right? So if I had x squared over x squared, that would become a 1. If I had x6 over x6, that would become a 1. And you could write the 1, so you'd have 3 times 1 times y, but there's really no point because the 1 isn't going to change anything, right? So we just kind of cross it out and make it disappear. Does it become a 0? No. It becomes a 1, but 1 times anything is itself. If it was a 0, everything would become a 0, so it does not become a 0. In the second one, same thing. I have an x common in both, so the x and the x cancel. I'm not left with a 0 on top, I'm left with a 1, right? Because 0 over something is not the same as 1 over it, right? Because that'll become a 0. So yeah, so we're going to cancel. So we're going to sort of solidify this rule a little bit further along here. So now, specifically, we're just looking at dividing a monomial, so the single term, by a monomial involving powers. So this just means a variable, like the same variable, same letter divided by the same thing. So I'm going to just write this out. I have a times a. The little dots mean multiplication, by the way. We also use these, which could become confusing. Probably should use brackets, but just means multiplication. We have all sorts of shorthand in math. But yeah, so I have 5 a's on the top and 3 a's on the bottom. So this can cancel this one can cancel this one, and this one can cancel this one. So all I'm left with is 2 a's on the top, or a squared. And then on the bottom, I'm left with a 1, but we don't have to write that, right? So I'm left with a squared. But the other rule, or the other way to do this, is using what we call subtraction, the subtraction method. So 5 take away 3. So when we have division, like in addition, in multiplication, we were able to add those exponents, right? So in division, we're actually able to subtract. So it's the opposite, which makes sense. 5 take away 3 is going to be a squared. So we have an a to the power of 2, which we also got in the first answer. So we can also use those exponents and then subtract them, and it makes our life way easier. So some rules. To divide powers of the same base, subtract the exponents and leave the base the same. So that's basically what we just did. We leave that variable or that base the same, and we just subtract those exponents. The 0 rule is any base to the power of 0 becomes a 1. So I mean, we could have went over this in the multiplication booklet, but if I have 2 to the power of 0, it's a 1. If I have, well, that kind of looks like a z anyways, b to the power of 0 is 1, and so on. So anything to the power of 0 is 1. And then there's this negative exponent rule. The reason this is brought up, I mean, it's really useful in all math, but as you go, if you are working in the booklet, you'll notice some of the booklets, and I'm going to do a little example at the bottom here, there's 2 formats. So if I have a to the power of -3, right, which is possible, we can have negative exponents. I can also write this as 1 over a cubed. It's the same thing. And you're probably asking why and how. Okay, so we have, let's say I had a to the 5 over a to the 9. So I have 5 a's on the bottom. Why did I pick 9? I don't know. And I have 9 on the bottom. 3, 4, 5, 6, 7, 8, 9. And I have 9 on the bottom. 3, 4, 5, 6, 7, 8, 9. I was committed to it. Okay, so I can cross out 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. I'm left with these 4 A's, right? So I'm left with just a 1 on the top and an A4 on the bottom. So this is great. That's one way to write it. But if I use my subtraction method and I went 5, take away 9, right? I'd get a to the -4. 9, a to the -4. And these are the same. a to the negative 4 is also 1 over a to the 4. And we saw with the two different methods we used, we got different types of answers, but they're the same. So if ever you see on an answer key 1 over or the numbers on the denominator on the bottom, if we wanted to bring that up, we could bring it up and make it a negative exponent. So another example of that. If I had x squared over y4, I could also write this. It's terrible. These are equivalent. I could also write it as x squared y to the negative 4. Those are the same. So if I don't want to have a fraction, I can bring that y up, but if I'm going to do that, I have to flip that exponent. So that's a quick explanation of that rule. Okay, so in this example, and the book gives plenty more of examples. I prefer the subtraction method, and most of my students honestly do. It seems to be a little bit more streamlined, but in this first solution, we have 6a to the power of 4, b to the power of 6 over 2a squared b squared. So what we're going to do is we're going to, and we haven't done a very complicated example yet. We're getting a little more advanced here. So we just take the coefficients, so the numbers in front, we're going to take those out and we're going to split it up. So notice how we split it up. 6 over 2, that becomes a 3. So 6 divided by 2 is 3. Then my a to 4 over a squared becomes a to the power of 2. And then b6 over b2 becomes b4. So what I could have done, and I mean, it is the exact same thing. 6 over 2 becomes a 3, that's for sure. But I'm going to go 4 minus 2 and b6 minus 2. So I get a2, b4. So I did get to the answer the same way, but instead of sort of figuring out which ones cancel, we can just do the subtraction method. So our coefficients we deal with independently. If you need to punch this into a calculator, that's totally fine. Sometimes it doesn't become a whole number, it stays as a fraction, and that's okay. We'll look at some of those too. Don't be scared of fractions. Lots of people are though. Okay. So, oopsie doopsie. Oh my gosh, okay. So, my 8 over 10, I'm just gonna write it out and just leave it. We'll figure out if we can reduce it later. I have 4 take away 4. I have Q7 take away 9. And I have R13 take away 9. So 8 over 10, it doesn't become a whole number, but it can be reduced. So we can actually get that into a lowest term fraction. And a really simple way to do that, we're going to pop over to the scientific calculator. We haven't seen it in a while. And I will show you a very quick way to, I mean, that's a pretty simple one to simplify. We would just divide them both by a common factor, but some of them aren't so simple all the time. So if I want to get into the lowest terms, I'm going to go 8, use my fraction button over 10, and equals, and it's going to reduce my fraction into lowest terms for me. So we divided both by 2, right? So 8 divided by 2 is 4, and 10 divided by 2 is 5. But again, at this level, this isn't the type of stuff I'm like expecting to see from you. You can use a calculator and just get your lowest terms fast if you need to, because sometimes the numbers will be a little bit more like trickier to use. So anyways, so we get 4 over 5, p to the power of 0, q to the power of -2, and r to the power of 9, 10, 11, 12, 13, 4. So that p to the 0 becomes a 1. I'm just going to cross it out. You could write it as a 1, but again, why write a 1? Like it's not really going to change anything. It just adds more numbers to the mix that we don't need. So we get our final answer, 4 over 5, q to the -2, r to the power of 4. This could have been written as 4r4 over 5q squared, right? The q squared could come down to the bottom. The 5 is already on the bottom. It's part of the denominator. So it can be rewritten as this way. Both are acceptable answers. Students typically like the negative one. It just seems to make more sense. I don't expect you to be able to flip back and forth, by the way. It's just to show you that there are different ways to show the answer. Okay. So the next one, we have 4 divided by negative a half. So again, you're going to pop over to your scientific calculator. I'm not going to pop it up again because just sake of time. We're going to go 4 divided by, you're going to use that plus minus key, 1, ABC key, 2, right? So you're going to divide by your fraction. So 4 divided by negative 1/2, it'll give you negative 8. If that's not something you remember how to do, you can go back to the calculator booklet or ask your teacher, but 4 divided by negative a half is going to give you a negative 8. So that's going to give me negative 8. And then x, I have 4 take away 2. And then for my y's, I have 7 take away 4. And then my z's, I have 10. So I have negative 8x squared, y 3, z 10 as my final answer. Okay. I don't know if I have one in the next slide, but while we're here and while I'm thinking of it, sometimes, like let's make one up, sometimes, and I'll show you what I mean. Like if we had, so sort of like the third question, so let's just make it easier though. If I had 4 over negative 2 x, we'll still do it squared, but then I had my z10 on the bottom, and my we'll just do a y7 on top. So 4 divided by negative 2 gives me a negative 2. My x, 4 take away 2 gives me a 2. My y, 7 stays as a 7. Now the question is, so in this one our z10 was on the top and that was great because we just kept it there. But in this one my z10's on the bottom. If I want to bring it up to the top, because there's no other z's to combine it with, but if I want to pop that up to the top, I can't just do that. I have to make it into a negative exponent, right? So on your answers, if you're going to bring that up, you have to flip that into a negative exponent. Or you could have kept it as negative 2 x squared y 7, and you could have just kept that z10 on the bottom. Totally fine with that answer as well. Just if it's on the bottom and you want to bring it up, it has to become a negative because that's that rule. So usually there's like one of those on the assignment, so I wanted to cover that because I actually don't know if I have one like that. Okay, now we have division, so the last 2 slides, division of a polynomial by a monomial. So if I have a polynomial being divided by a monomial, so the top is 4 different terms being divided by 1 term on the top, what I do, or can do, I just realized I can make my pen smaller. Oh my gosh, game changer. I can separate these into a bunch of different fractions. So I'm going to like group all of these. It looks like a disaster, but you'll bear with me here. Let's maybe go a little bit thicker than that because it's pretty small. Okay, so in the first one, I'm just going to write it out as separate fractions. So I have 12x4 over negative 2x squared plus 16x cubed over negative 2x squared minus 8x squared. Oh my gosh, I can't read it now. Yeah, okay, that's right. 8x squared over negative 2x squared plus 4x. Sorry, I had to just adjust my headset there. Over, 4x over negative 2x squared. So basically it just means I'm going to separate them all into their own little thingamajiggies and then simplify. So 12 divided by negative 2 is going to give me a negative 6. Again, use your calculator if you need to. Then I have a 4 take away 2. Then my 16 divided by negative 2 will become a negative 8. So I went ahead and wrote that plus sign, but I'm going to go erase it because I don't really want to have to do more work than I do. That'll become a negative 8. And then I have x3 take away 2. And then my negative 8 divided by negative 2 becomes a positive 4. x2 take away 2. And then I get minus 2, because 4 divided by negative 2 is negative 2. x1 take away 2. Okay, so all I did was take all my numbers, like my coefficients, and simplify them using a calculator or whatever. And then I subtracted my exponents with my variables that were the same. So negative 6x squared minus 8x to the power of 1. You can put the 1 there, you don't have to, doesn't matter. And then 2 take away 2 is going to give me a 0. And then negative 2 to x to the power of negative 1. So this 0 will become a 1. So we're going to simplify this as much as we can. So I get negative 6x squared minus 8x plus 4 minus 2x to the negative 1. And then the question is, and sometimes you can I simplify plus 4 minus 2x to the negative 1? And then the question is, and sometimes you can I simplify it any further? But I can't, right? Like each of these, we're back to our addition subtraction rules. Each of these variables has a different exponent, and then this one's just a constant. So I can't actually simplify that any further. So that would be my final answer. Okay, let's try the next one. Okay, so the next one, same thing. We're going to split it into 4 fractions. So I have 6p squared q cubed over, I'm going to stop saying everything out loud because that's probably super annoying. And while I'm writing all that out, again, you do not need to write this step at all. The more work you show, the more marks part marks you get it, like if you get the question wrong. But it's whatever your brain wants to do. You also don't have to show every step I show. Like if you went to school with a teacher that told you you had to do it this way or it was marked wrong, even though the solution was wrong or right rather, like in this program, it's not like that at all. So whatever method you do in your head or on paper is fine as long as it makes sense to you. And sometimes maybe I'll even get you to explain it to me because I also think it's really cool that some people think differently and do things differently. I find it quite fascinating. Anywho, 6 divided by negative 3 gives me a negative 2. P, I'm not going to write all my exponents out this time. You know what? No, I will. Will I? Just going to be really, no, it's fine. Okay, 2 minus 1, q, 3 minus 1. Negative 9 divided by negative 3 will becomes a positive 3. And then I get p, 2 take away 1, q, 1 take away 1, so that'll become a 0. Oops, got ahead of myself. Plus negative 3 divided by negative 3 is 1. P, 1 take away 1, q, 2 take away 1, and then minus, like minus 1. I'm not going to write the 1, but yeah, I'll write the 1, whatever. P, 1 take away 1, and q, 1 take away 1. Okay, so I get negative 2, and then I get p to the power of 1. We'll just leave it like that. Q squared. Okay, so negative 2p1 q squared plus 3p. 2 take away 1 is 1. Q to the 0, but you know what? I'm just going to cancel it out. I'm going to cancel this one out too, and I'm going to cancel these two out. You could have also done it up here if you wanted. Like, you can go away and you can go away. You know, you could have done that too. But anyways, I'm just doing the subtraction method just to keep things a little bit, I don't know, similar. Okay, plus q, because 2 take away 1 will become a 1. I'm not going to write the 1. You could though. And then minus 1. So the biggest sort of mistake students make in this last term is to just think it becomes a 0, but there's still that negative 1 out front. And because this becomes a 1 and a 1, it's all multiplied together. So I do have that negative 1 at the very end. So you are probably, or have at some point in this video, or maybe you haven't, and that's fantastic, but you may have yelled, "What is going on? There are so many rules. This is awful. This is horrible." And most people are right there with you. But I will say, the more practice you do, the more questions you ask, the more just the more practice you do, you'll get better at it, right? Like if this is a brand new concept for you, that's fine. Like give yourself some grace. Allow yourself some time to learn the concepts. And the great thing about this is you can pause me, you can fast forward, you can rewind. And then also you can meet with me or your teachers and ask more questions if it doesn't make sense to you for clarification. So please don't give up. Algebra is hard. It is really hard. So don't think that you're not, you know, able to do this. It's just hard right now, but it doesn't make it impossible. I've seen students who, you know, came into the program and weren't able to add whole numbers together and they got through all of this. So it's just a matter of taking time and practice. So I just don't want you to give up. But maybe you've kept up with me this entire time and that's amazing. I hope so. Okay, last one. The reason I threw this one into there is because it's the super annoying fraction in the bottom. So I wanted to do one with a fraction. I'm not going to write out each one this time just because it's just really a pain in the butt. But in your calculator, you're going to, you know what? And so since I'm not writing it all out, let's bust out the calculator one last time. This is the last slide anyways, bear with me. Okay, so for the first one, we had 32 divided by, I think it was a negative. Let's pretend like it was. It might not have been though. But anyway, if it was a negative, we're going to hit that one. And then 1 over, right, that's our fraction button, 2 equals, that's going to give me negative 64. So lots of students probably would have just divided by 2 and got like 16. But when we divide by a half, it's actually the same as multiplying by 2. But you don't need to know that. You can just use your handy dandy calculator and divide by the fraction. All right, it wasn't a negative. That's hilarious. So it's fine. It's 64 still, but it's not a negative. 64. It's blue now, so cool. And then we have, let's deal with our x's. So I have x3 minus 2, so that's an x. I have y2 take away 2, so that'd become a y0. Let's just write it anyway. And then I have z1 take away 1, so that actually also becomes a 0. Then I have negative 4 divided by 1/2, so that'll become a negative 8, so that one at least stays as a negative. And then I have 1 take away 2, so that becomes a negative 1. Maybe I should have written it out, but hopefully you're keeping up with me so far. So I have a 1 take away 2, so that's a negative 2. And then my y2 take away 2 becomes a 0. My z1 take away 1 becomes a 0. And then negative 18 divided by a half becomes negative 18 divided by a half. Yes, okay. Same as multiplying by 2, so that becomes negative 36. X, 1, so my x has 1 take away 2, so negative 1. My y is 2 take away 2, so it's a 0. And then my z is 2 take away 1, so just a 1. Yeah. Okay. Gone, 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 gone. So I'm left with 64x minus 8x to the negative 1. You're gone too. Minus 36x negative 1z. And that is my final answer because I cannot combine these. I have an x, then I have an x with a negative 1, and then I have an x with a negative 1 with a z. So that is your final answer. And that's it for today's lesson. Again, just if you have any questions, please ask. If you hate all of this, most people are right there with you, but please ask questions. Don't give up. It is hard stuff. We also got through a lot in one lecture, so if you need to go back and rewatch stuff, that's totally fine. But yeah, thanks for watching.